Let's solve this problem. This problem is talking about we already know the specific heat for iron, lead, and zinc. Okay, yeah, and we're talking about if we have 1 gram of each of the metals, and start with the 100C and put those metals into the water at 25C is about 10.0 gram. Okay, what's the final temperature if we put for iron, put the iron metal, lead, and zinc into the water? So what's the final temperature for each of this? Okay, to solve this problem, we need to remember ours. Okay, so when the metal put into the water, the temperature of the metal will go down, and the water temperature of the water will go up, will rise up. So what's the temperature? So actually, the energy of the heat of the metal is decreasing, while the heat of the water is increasing. So what's the water gain actually is what the metal lose. Okay, so we need to remember we have equation like that, which is the Q metal is equal to the negative sign of the Q water. Okay, so and we know the Q is equal to the C time M time delta T, which is C time M time the final temperature minus the initial temperature. Okay, the C here is the specific heat. The M here is the mass of the either metal or the water. The change of temperature. And here the change of temperature is the final temperature minus initial temperature. Okay, so if we put this equation into the first equation, then we can figure out, okay, so the specific heat of the metal time the mass of the metal time the final temperature of the metal minus the initial temperature of the metal should be equal to negative sign of the C specific heat of the water times the mass of the water times the final temperature of the water minus the initial temperature of the water. Okay, and then let's see what we have in this equation. And also, I strongly recommend you can write down the initial parameters here, and then you know what we miss. Okay, what things we need to solve. Okay, for the specific heat of the metal, and we have three metals. We have iron, which is 0.470. Here is a joule per gram per Celsius. And we have a specific heat of lead, which is 0.130 joule per gram per Celsius. And here we have a zinc. It's a 0.388 joule per gram per Celsius. Okay, and here what else we have? We have the mass of the metal. Okay, it doesn't matter it's iron or the lead or zinc. Those are all 1.00 gram. Okay, and we have the initial temperature of the metal. Okay, it doesn't matter which metal is always here is 100 Celsius. And we also have, okay, in another side, we already know the specific heat of the water. This is already know this is given number, which is 4.184 joule per gram per Celsius. And we have the mass of the water, which is 10.0 gram. And we also know the initial temperature of the water, which is 25.0 Celsius. Okay, so here we don't know, here, if you look at this equation, you can figure out, okay, we already know the metal, the specific heat of metal. We know the mass of metal. We know the initial temperature, and we know the specific heat of water, the mass of water, and the initial temperature of water. So what we don't have here is the final temperature of metal and final temperature of water. And here, this is what we're looking for. We're looking for the final temperature of the mixture. Okay, and you can think about, if the metal put into the water, what happened? The temperature of water is going up, the temperature of metal is going down, and eventually we will have the temperature of the final temperature of the metal actually is equal to the final temperature of the water. Okay, so those two are the same. Okay, so we can change our equation a little bit, which is the C metal time m, the mass of metal times the final temperature minus the final temperature of the mixture minus the initial temperature of the metal is equal to the specific heat of water times the mass of the water times the final temperature of the mixture minus the initial temperature of water. Okay, so then you can just put everything, the parameter here, into this equation. Then we can solve the problem. We can do this one by one. Start first. We will start with iron. Okay, so the specific heat of the iron is a 0.470 times the mass, which is 1.00, and the final temperature minus initial is 100. Then here is equal to negative sign. Don't forget the negative sign. 4.184 times 10.0 and time the final temperature minus 25.0 Celsius. Okay, and then we just here, this is simply just one unknown here, and then we just solve this problem. Here is a 0.470 T final minus this minus 47.0 and equal to this here is a negative 41.84 times T final minus 25.0. Okay, and then let me just extend this a little bit. We move this down. Try to solve the problem. Okay. So here is just a 0.470 final minus 47.0, and here is minus 41.84 TF, and minus we can calculate. Okay, so this is a 41.84 times 25.0, and here this is positive 1046. Okay, positive 1046. Okay, and then we can just move the unknown on the to the left side and put the numbers on the right side, which is 0.470 plus 41.84 TF equal to 1046 plus 40. Okay, and then the final temperature is going to be 1046 plus 47.0 divided by 0.47 plus 41.84. Okay, and then we put that into the calculator. This one plus 47.0 is equal to this, and divided by 0.47 plus 41.84. Okay, so the final number is 25.83. Okay, 25.83. This is a Celsius. Okay, yeah. So this is for here. This is iron. Okay, and then we can solve the lead. Lead actually is the same thing. Let's check. Okay, lead, just the same equation. We're going to use the same equation to solve the both iron, lead, and also the zinc. Okay, so the only difference is the specific heat here. So for the lead is 0.130 times 1.00 times TF minus 100 equal to negative 4184 times 10.0 times T final minus 25.0. Okay, and here we got is 0.130 minus 13.0 equal to 0.41.84 T final plus 1046. Okay, so the right side is the same thing. Okay, let's move down a little bit to finish this equation, the calculation. Okay, let's move down. Okay, here, so final here. Okay, and then we put the unknown on the left side and put the number on the right side. Here is a 0.130 plus 41.84. Okay, equal to 1046 plus 13.0. Okay, the final temperature is 1046 plus 113 divided by 1.13 plus 41.84. Okay, and then you put this into the calculator, and let's solve 1046 plus 13.0 equal this divided by parenthesis 0.13 plus 41.84 parenthesis. Okay, so here is 25.23. 25.23 Celsius. Okay, and then we can solve another, which is the zinc. We do it is exactly the same thing. Okay, the only difference is we're going to change the specific heat for the iron, for the metal. So the specific heat of the zinc is a 0.388. So we put 0.338 here, which is 0.338 times 1.00 times T final minus 100 equal to negative 4184 times 10.0 times T final minus 25.0. Okay, So here it's going to be 0.338 T final minus 33.8 equal to negative 41.84 T final plus 1046. Okay, so again, put the unknown to the left, put the number to the right. So here is a 0.338 plus 41.84 T final is equal to 1046 plus 33.8. Okay, and then the T final is equal to 1046 plus 33.8 divided by 0.338 plus 41.84. Okay, and then again put it into a calculator. So 1046 plus 33.8 equal to this divided by parenthesis 0.338 plus 41.84 parenthesis. So this one is final temperature is 25.60 Celsius. Okay, so here this is for the zinc, and this number is for the lead, and on the top we see this number is for the iron. Okay, so you can make an order now. Okay, so what's the question asked for? The question is asked for the order of the temperature of the final mixture from the lowest to the highest. Okay, so the lowest to the highest. The lowest is the lead, right? The lowest is the lead. So the final temperature, the order of the final temperature. Our final temperature actually is lead, which is 25.23 Celsius, and this is the lowest, to the zinc, 25.60, and to the iron, which is 25.83. Okay, so this is how we solve the problem. I hope you're get to be familiar with how to solve this kind of question. Okay, then see you later.